In this example, we'll be finding the third roots of unity. So how do we find roots of unity anyway? So roots of unity is just saying we have a complex number, and when we raise this complex number to the power of n, it equals 1. So when we find the roots of unity, we want to find the particular complex number or complex numbers for which this holds true. In this case, we want the third root of unity, which means we want n to be 3. And we also note that we can write out 1 as 1 plus 0i, so we're writing its complex number representation. And if we were to write the exponential complex number representation of this number, of course we know r square is equal to a square plus b square, so r square is 1 square, which implies that r is 1. And we know that theta is equal to tan inverse of b over a, which is 0 over 1, right? So that's tan inverse of 0, which since we know that a is positive, this answer is 0. Okay, so we know that this can be written out as r into e to the power of theta j or theta I, right? So in this case, r is 1 and theta is 0, so it's e to the power of 0i. Okay, so we've written it out this way, but note that we could add 2 pi to this and this would still hold true. That's because if this is our value, we're going to go around the circle 360 degrees and we'll still land on the same point. In fact, we can go around the circle twice and we'll still land on the same point. So that would be 2 pi k, because you can go around the circle k times and we'll still land on the same point. So theta is equal to 0 plus 2 pi k, which means that this is equal to 1 into e to the power of 0i plus 2 pi ki. And we know that e to the power of 0 is 1, or e to the power of 0i is 1. So this is e to the power of, so 1 into e to the power of 2 pi ki. Okay. Now we've concluded that z to the power of n is equal to e to the power of 2 pi ki. So we're going to take root n on both sides of this equation. This implies that z is equal, so d to the power of n, and we're going to root n this, so oops. Okay, so root n on this side is equal to e 2 pi ki, root n on this side. Of course, this is the same thing as the power of n, root n, right? This and that. Okay. So we know that z to the power of n, root n, is just equal to z. So we've said that z is equal to this thing. And we want to find out what z could possibly be. So we know in this case n is 3, so z is equal to e to the power of 2 pi ki over 3. And now we need to vary this k, because in this part we said k can be 0, it could be 1 revolution around the circle, 2 revolutions around the circle, etc. So when do we stop iterating to several values of k? So we could start out at k is equal to 0, then move on to k is equal to 1, then k is equal to 2, etc. But when do we stop? So notice in this case, when we reach k is equal to 3, we're actually going to get e to the power of 2 pi 3I over 3. And this will cancel out, and this will give us e to the power of 2 pi I. This, of course, is the same thing as e to the power of 0I, because 2 pi is it's just a rotation around a revolution around 360 degrees. So these two values will be the same. So we need to stop iterating through k when we reach n minus 1. So we're going to start from k is equal to 0, then move on to k is equal to 1, 2, etc. until we reach n minus 1. So let's look at that more closely. So let's try writing out the values of z in this case. So if k was 0, this would just be e to the power of 0I, which is e to the power of 0, which is 1, right? Then for our second root, k is equal to 1. So when k is equal to 1, it'll give us, so z will be e to the power of 2 pi 1 into I, so that's 2 pi I over 3. So 2 pi I over 3. And we can convert this into polar form, since we know that in polar form, this is r cosine theta plus I sine theta. And we know r is just, so r is just this value. So r is 1. So you can write this as 1. And theta is just this part. So yeah, it's 2 pi over 3. So cosine 2 pi over 3 plus I sine 2 pi over 3. Right. Similarly, we could plug in k is equal to 2, which is just this. Now what happens when we plug in k is equal to 3? When we plug in k is equal to 3, we'll get e to the power of 2 pi I, and this is the same thing as e to the power of 0I, and we've already written this root out over here. So it's a repetition, and hence we don't include it. This is why we stop at k is equal to n minus 1. So our 3/3 roots of unity are just these things. 1, this, and this. Yep. Thanks for watching.